is a natural satellite of Saturn, known as a world of pure ice. This purity makes it one of the celestial bodies with the highest solar reflectivity in the solar system. Recently, NASA scientists used data collected from the Cassini spacecraft.
After synthesizing images, they discovered evidence of fresh ice appearing in the northern hemisphere of the satellite.
They believe this fresh ice originates from within Enceladus. This could be a potential signal for extraterrestrial life. Let's explore together in today.
Enjoy watching the video. Don't forget to subscribe to the Oddity Odyssey channel and turn on notifications to all.
Now, let's go explore.
Known as the sixth largest natural satellite of Saturn, Enceladus has a diameter of about 500 kilometers. With this size, it is classified as a relatively small satellite. On its surface, Enceladus is mainly covered by a layer of clean ice. This clean ice layer makes it one of the celestial bodies with the highest reflectivity in the solar system.
First discovered on August 28, 1789, by astronomer William Herschel, but Enceladus received very little attention. Until Voyager 1 and 2 flew near the satellite and sent the first images back to Earth. In 2005, when the Cassini probe flew close to this satellite, humanity got more detailed views of Enceladus' surface.
Particularly, the Cassini probe repeatedly detected plumes of water vapor escaping from the satellite's south polar region. More than 100 geysers erupting on the surface of this satellite have been confirmed.
After erupting, some falls back to the surface as snow, while the rest escapes into space, creating material in Saturn's E-ray. Recently, when scientists analyzed images sent by Cassini, combined with infrared observations of Enceladus, they mapped the satellite's surface.
Data show that not only do water plume eruptions occur at the South Pole, similar phenomena also exist at the North Pole of the satellite.
This indicates that Enceladus has more surface activity than scientists previously thought. In 2005, when the Cassini probe measured the mass of water plumes ejected from the surface,
scientists calculated that about 250 kilograms of water vapor was ejected per second at that time.
Additionally, in 2019, through spectral analysis of the ejected water vapor plumes, studies showed the presence of nitrogen and oxygen containing amines. This discovery is significant. They believe these could be organic precursors related to biology. Moreover, beneath the ice-covered surface of Enceladus, researchers believe there must be a very large salty ocean. Models indicate that this satellite may have a large rocky core allowing ocean water to flow over this core's surface, thereby generating heat and chemical transfer at the ocean floor. This model could give us hope that more complex organic compounds might appear in the satellite's ocean floor area. And then they could be metabolized by microbial forms to provide energy for life. If life could exist on Enceladus, this would indeed be extremely interesting. Perhaps only simple life forms could exist here, but it would be evidence proving we are not alone in the universe. But geographically, Enceladus is a satellite of Saturn, so the amount of sunlight it receives is very weak.
According to calculations, the average temperature at noon on this satellite is about -198 degrees Celsius. This temperature creates an icy surface in the satellite.
Almost all known life forms cannot survive on such an icy surface. At best,
we can only hope for life existing beneath the satellite's salty ocean.
On the surface of Enceladus, it has long been famous for its tiger stripes.
These tiger stripes extend about 130 kilometers and are usually parallel to each other, with distances between them of about 35 kilometers.
Last year, scientists from the University of California published a research paper. They used models to explore how physical forces on Enceladus create these tiger stripe fractures.
The research team also wanted to understand why these tiger stripes repeatedly spaced at the satellite's south pole.
Finally, they concluded that the cracks forming the tiger stripes on Enceladus
not only appear at the south pole,
but are also confirmed
in the satellite's north pole. However, in the South Polar region, the tiger stripes are more clearly expressed. They also discovered that seawater still erupts along the parallel tiger stripes. This causes many other parallel watermarks to form as snow and ice accumulate along the edges of the initial cracks.
These continuous crack activities make Enceladus even more of a focus for scientists. To date, we have undeniable evidence that
beneath Enceladus' surface, water exists in liquid form along with conditions suitable for the simplest life to exist.
The detection of hydrogen,
Carbon dioxide, and methane suggests that bacteria on Enceladus might be absorbing hydrogen or carbon dioxide and releasing methane gas, similar to living environments in volcanic geological layers on Earth.
This is a form of life that doesn't require solar energy but relies solely on heat from the satellite itself. Enceladus is quite small with a diameter of only about 500 kilometers. Therefore, its gravitational force is very weak.
As a result, the escape velocity on this satellite is only about 0.239 kilometers per second, equivalent to 860 kilometers.
At this velocity, if you had the opportunity to stand on Enceladus and fire a bullet from a gun, the bullet would fly away forever without ever falling back.
Located at an average distance of 238,000 kilometers from the planet's center, Enceladus takes about 32.9 hours, or 1.37 Earth days to complete one orbit around the planet.
This is considered a relatively fast orbital period, much faster than the Moon's 27.32-day cycle around Earth. Like most of the planet's satellites,
Enceladus also rotates synchronously with its orbital period.
This means one side of the satellite always faces the planet, while the other always faces outward. As High-Yen presented, the water vapor plumes erupting from Enceladus somewhat resemble comets. When ejected from the surface, some falls back creating snow showers, while the rest is ejected into space and is believed to be the source of material in the planet's E-ring. As we know, this planet is notable for its rings. Among them, the E-ring is the outermost and extremely wide.
It is thought to consist of very small rock and water ice particles, only about 1 micrometer or smaller. Calculation models show that the planet's E-ring is unstable, with a lifespan ranging from 10,000 years to 1 billion years. Therefore, the material particles forming this ring must be continuously replenished.
And it seems scientists generally believe that the material in the planet's E-ring is created from water vapor and ice eruptions from the satellite Enceladus. This very fact has led scientists to hypothesize that, since Enceladus loses over 200 kilograms of material per second, if this loss had occurred continuously over the past 4.5 billion years, it would have lost about 30% of its original mass. To date, Voyager 1 flew past Enceladus at a distance of 202,000 kilometers in 1980. Next, Voyager 2 approached closer at a distance of 87,010 kilometers in 1981. And the closest approach was by Cassini in March 2008, when it flew just 48 kilometers from Enceladus' surface. But the Cassini mission ended when the spacecraft ran out of fuel and was navigated to crash into the planet's atmosphere on September 15, 2017. To date, many projects aimed at exploring the mysteries of the satellite Enceladus have been proposed but were all cancelled. Hopefully, in the near future, scientists will have plans to probe and explore the planet's satellite Enceladus, one of the rare moons in the solar system with high expectations for extraterrestrial life. So today, Talk 2V and Not Together explore the mysteries on the planet's satellite Enceladus. Wishing you all an enjoyable video view. And now, please continue selecting videos on the left or right side of the screen to join Talk 2V in decoding other mysteries of the universe. Looking forward to seeing you in the next videos. Goodbye everyone.